So let's go ahead and start off with the first protocol that you're going to have to know about. And that's going to be FTP. Okay, so just to quiz you, what is the port number for FTP? Do you remember it? Well, hopefully that was your answer, port 21. So let's go ahead and now get some hands-on with FTP in this trace file. Now you're going to notice throughout this video, sometimes I'm going to set a filter in Wireshark for the name of the protocol, and sometimes I'm going to set it for the port number itself. But what's the difference? Well, let's actually learn this right out the gate. We're going to be filtering for FTP. So if I come in here and I go to display filter and I just type in FTP, check out the number of packets that I have. I've got 33 packets that are displayed. Notice what I don't have. I don't have anything that says TCP here. So I don't have any of the handshake. I don't have any of the acknowledgements or any of the resets or anything like that. I just have whatever packets actually carried FTP data. But if I want to see some of those other supporting packets, especially the ones that show me the handshakes and such, that's where I need to go in and I need to do TCP port == 21. So now check out how many packets we have. We have 101 packets. So when we filter on port number, we're taking a look at it from the TCP perspective, including any payload. If we filter from a protocol, we're only focusing in on that protocol, not on the TCP overhead information. That's why personally, a lot of times when I'm doing analysis, I'll use the port number to set the filter instead of the actual name of the protocol. Now, something that you're going to need to know about FTP is historically FTP has used at least two ports. One was a control port where it established a login and an initial connection like we see here on port 21, but then data would be exchanged on a different port. Sometimes that's port 20 or a different port that's designated within the control traffic. So that's fuel for another conversation, but what we want to remember is usually it's port 21 and then if not port 20, another port to actually move the data. So let's go ahead and take a look at FTP and how it works. So here we can see FTP is a TCP-based protocol. We can see the TCP handshake here, SYN, SYNAC, ACK. And notice that FTP is clear text. That's why it's kind of fun to play with. We can see here, here's a user login, and then the server comes back and says, okay, go ahead and give me that password. And look at our password is clear text password. You're also going to see in this trace file that there's a lot of the different request methods that we have. So go ahead and explore some of those on your own. Might get you a little bit more hands-on with FTP. Now you're going to notice at the bottom of the FTP conversation, you're going to see basically what looks like a port scan, and you should. That's exactly what it was. Here, one station was testing this other station with a lot of different SYNs and just seeing those resets as a part of a scan. Okay, so, but the actual protocol itself we can see here is up at the top. Now, something you're going to notice as I'm going through this is that my time column is listed as the time of day, and that's what I would suggest for you. Instead of starting at 0 and going through it like a stopwatch, instead let's go ahead and go up to View, Time Display Format, and we're just going to do time of day. Now, why are we doing this? Because to create this trace file, I had to merge a lot of different other PCAPs together to get all of these protocols in one place for you. And they came from a lot of different time periods. So to make that easier, let's just use time of day, and that'll simplify our analysis, not get all tied up with the time. All right, so now that we talked about FTP, let's talk about the next one, SSH, Secure Shell. Now, what is the port number for SSH? Do you remember? Well, hopefully that's the one that you got. All right, port 22. Let's go ahead and talk about port 22 as we're setting a filter for it. So let's go back to our trace file. Let's set up a filter for port 22, and let's see what we got here. Now we can see that there's a few SYNs. We see a reset there. That was also part of that scan. But also below that, we can see that we have a little bit of SSH conversation. Now, there's not a whole lot of SSH in this trace file. And you're going to find that if you ever capture SSH with Wireshark, it's encrypted, right? So, and we want it to be, right? When we're interacting with a network device or if we're SSH into a server, we want to make sure that that's encrypted traffic. We're going to talk about why that is in just a moment. But as we can see here, we establish our handshake. We go to SYN, SYNAC, ACK, and then the server actually comes back and it just gives us a version. Here we're just doing a version request for it. So let's come down and see what kind of SSH we're dealing with. If we open up SSH, we can see this is SSH 2.0 Open SSH and then Debian 8 Ubuntu 1. So that just gives us an idea of what type of SSH server that we're talking to. Now just remember about SSH, that's how we're going to remote into a device to do some control and configuration. Okay, so let's just remember that. SSH, port 22. All right, let's move on to the next one. Okay, Telnet. That's often one that you're going to see come up on a certification exam. Certainly one that we want to know if we're into networking. What's the port number? Hopefully that's what you got, port 23. Now, there's a reason why you don't see a whole lot of Telnet anymore. Let's find out what that is. Okay, let's go ahead and go up to TCP port, and we're going to come back and just say port 23. So here's some Telnet stuff we have in this trace file. You can see I got 104 packets. Now, Telnet uses TCP as a layer 4 transport protocol. So we can see that there's our handshake. And here we got Telnet data, Telnet data. Now, here's what's kind of fun about Telnet. If we take a look at our ASCII characters, or we take a look at the clear text view, we're going to start to see that there's some data in here. So if you come down to packet 338, you can start to see some clear text stuff come through. In fact, one way that we can analyze Telnet with Wireshark is just to click through and to take a look at everything one packet at a time. Or what we can do is we can do a follow TCP stream. So let's do that. If we right click any Telnet packet that's in this first part of our conversation, we can come down to follow, and we're going to do TCP stream. Basically what this does is Wireshark takes the raw data out of each of these Telnet packets, or whatever TCP protocol we're using. It takes the payload and it assembles it in one place, and then it allows us to manipulate how we view it. Now right now we're showing this data as ASCII characters, okay? So if we wanted to, we could say raw. So do I just want to see the actual hexadecimal values that made up this flow? Well, that's not very useful for me. I'm going to go back to ASCII. So here I can see all of this was sent over clear text. This is really what a clear text protocol is. Now in this, all I did was I just telneted into a metasploitable server. And my purpose here was just to get some data going that we could take a look at. Now notice the login. Telnet echoes things. So we can see in red, that's the client sending data to the server. The blue is the server coming back to the client. Okay, so notice that the client sends MSFADMIN. Okay, so MSF admin. And then in blue, right away, the server is actually echoing back every character. If I send M, it echoes back M. If I send S, it echoes back S. To make this easier for me, what I can do is I can come down to the entire conversation. If I just want to see from the client to the server, then I can just take a look at this one direction. And this is where I can see MSF admin all together without the echoes, and then exit. So here we can see the login and then the password and then just exit very simply. Now this is also interesting to look at if you ever telnet into a network device. You can see whatever you show on your screen with Telnet. You can also see that within the packets as well. And really, due to the clear text nature of how Telnet works is really the reason why we don't use it as much anymore. Now we're going to be using more SSH because it's going to be encrypted. All right, so that was Telnet. So let's go and go on to the next one. All right, SMTP. What's the port number for SMTP? All right, very good. Port 25. All right, so there's three major mail protocols, and this is one of them. SMTP, also in a minute, we're going to take a look at POP, or Post Office Protocol, and we're also going to take a look at IMAP. Those are your big three. Okay, so something that you want to remember about SMTP as opposed to the other email protocols is that you're going to use SMTP to send emails, okay, from an email client to that email server. We're sending the email. You retrieve it with the other protocols that we're going to talk about in a little bit. But let's get back to our port. So we're going to come up here to our display filter. Let's go ahead and type in tcp.port == 25, and that's going to show us our SMTP traffic. Now, SMTP can either be encrypted or unencrypted. We actually have examples of this, or both of them, here in this PCAP. If we take a look at the first one, here we can see that we have TCP connections in SYNAC-ACK. So here we can see that the server comes back and it's telling us its version, and we can come down to SMTP. It shows us the type of server that it is. We can come down here and we see that the client is saying hello. Now, to make this a little bit easier to read, if we just right click here, we can come down to follow TCP stream. All right, so here with our follow TCP stream, we can actually see all of this data in one place, just like we could with Telnet. Now we can actually read this email. Now, this is just a test email that was being sent out. It's just something to take a look at. And we can see that the email address that it's being sent to. After the email is sent, afterward we can see, okay, the message was accepted. We'll go ahead and quit, and we're going to sign off. But if we come down here to close, also in our trace file, let's go ahead and back out from our stream filter. We're going to come back and just do another TCP port equals 25. And so if you scroll down a little bit further, if you come down to packet number 1407, around there, we see another connection over port 25. So let's go ahead and see what happens here. This time I'm just going to right click. I'm just going to say, instead of follow TCP stream, let's come to conversation filter TCP. That's going to filter in just that one conversation. This time we set up our TCP handshake. We go ahead and establish ourselves with the server, say hello, but notice what happens. The server comes back in packet number 1413. If we expand out the response, we can see that the server says, hey, start TLS. Client says, cool, start TLS. Let's go ahead and start up a transport layer security conversation. Okay, so this is where we see client hello, server hello, and that will establish a secure connection between the client and the server. Now the rest of this is going to be encrypted. So this time, if we right click, we say follow TCP stream, we can see the initial SMTP information. After that, this is what the email looks like. A lot different than before. We don't see that clear text, ASCII characters, readable stuff. This is actually encrypted. So remember, the SMTP over port 25 can either be encrypted or it's possible to use TLS over port 25. So what should we look for with SMTP? Well, a couple of the port numbers that you want to keep your eyes open for is going to be 587 and 2525. There are some other ones, but those are going to be the big ones. Now that is going to be secure SMTP, and that's going to be non-clear text readable on the wire with Wireshark. All right, so let's go on to our next protocol. How about this one? DNS. Okay, so what's the port number for DNS? 53, there we go. Now this is going to be a little bit of a shift for us. Let's see why. Let's go ahead and go to our trace file and let's pop in port 53. Now here I can see I have some scan traffic. We went ahead and tried to establish a connection over port 53, but notice that I don't have any DNS information here. This is all just TCP handshake info. That's one reason why I like to have TCP segment length on my Wireshark profile, because then I can see whether there's a payload that's actually being carried by this frame. In this case, this is all just headers. It's all overhead, right? So SYN, SYNAC, reset, those kinds of things, but no actual data. Well, what's wrong here? Well, first of all, DNS, while it can support TCP, the majority of the time you're going to be running DNS over UDP. Okay, so let's go ahead and change this from TCP port 53. Let's go ahead and back this up. Instead, we're going to do UDP, all right? Port 53, and here we have one DNS call. Now notice when Wireshark recognizes DNS, when it actually sees that payload there, it's able to go, oh, this isn't just UDP, this is DNS, this is great. So when it sees that actual application using it, that's why instead of seeing UDP here, we're actually going to see the application itself, and that's going to be DNS. All right, so here we can see a request for DNS go. 34 milliseconds later, we see a DNS response. So DNS, there's a lot of different ways we can use it, but if you just keep it very simple, it's the phone book of the internet. When you go out to a web browser and you type in a name, DNS is resolving that name to an IP address that you can then go connect to. But how do we find out about DNS? How do we know what our DNS server is? Well, that brings us to our next protocol that we want to make sure we know, and that is DHCP, Dynamic Host Configuration Protocol. All right, so what port or ports does it use? Well, in this case, we actually have to know about two of them. Okay, so just remember this: 67. What's the other one? 68. All right, basically one's a client, one's a server. And let's take a look at that in Wireshark. So this time in Wireshark, instead of denoting a port number, what I'm going to do is I'm going to come back here. I'm just going to say DHCP. All right. So here we have the 4 packets that make up a DHCP conversation. And this is when we first come onto the network. We don't know who we are yet. We don't yet have an IP address. We don't know who our DNS server is. We don't have our gateway or what our subnet is. We're just coming up, we're waking up, and we're just joining this network, and we need some help, right? All we know is our MAC address. So with DHCP, we're able to find, first of all, that's why it says discover. That's the first packet there. We're able to find who out there is offering DHCP. That DHCP server responds and says, oh, you're new here. You want an address? So here you go. Dynamic Host Configuration Protocol, that's what we're using. Notice for a second the port numbers. If you take a look at UDP, so the server is going to be using 67, port 67. The client usually uses port 68. Okay, and again, that's UDP 67 and 68. Now Wireshark recognizes that, so we can go a little deeper into DHCP without going too far for the purposes of this video. But here we have the client address that was sent in the discover, and now the server is coming back and saying, oh great, okay, here's an address for you. Here's a subnet mask, here's a lease time, here's DHCP, and usually in many cases you also get a DNS in there as well. And in some cases you'll even get more instructions if you're a phone of who to download your configuration from and so on. All right, so 4 packets, discover, offer, request, acknowledge. That's the flow for DHCP. It's UDP based and there's 2 ports. What are those again? 67 and 68. Next, let's just keep on going in the 60s, right? We had 67, 68. Let's go ahead and go to port 69, and that is, what's the name? Let's do it reverse here, okay? We know the port 69, what's the name? TFTP. Good job if you got that, all right? So port 69, TFTP. Okay, so let's take that closer look at TFTP, Trivial File Transfer Protocol. Let's get into Wireshark. Now, if we go to the beginning of our conversation here, the beginning of this trace file, here we can see we have a read request. So basically, this protocol is used for moving files, but unlike FTP, it just does it in a more simple way. Okay, so there's a lot going on here, but let's just go ahead and keep this simple. Right here, the client is just saying, hey, give me this file, rfc1350.txt. Now, notice that this is over UDP, right? So this is a UDP exchange. This isn't over TCP. That's why we don't have a 3-way handshake. That's why we don't have to set up this connection or conversation. Really, this is just best effort. Go get that file and let's see what happens. So first we ask for that file, and notice right after this, at least in this conversation, we're no longer using port number 69 here. Now we're using these higher numbered ports, and we can see that this is data actually starting to come across, and Wireshark is recognizing it as TFTP. Now, like its cousin, FTP, TFTP as well can have a control port or a control conversation, and that's what we see in port 69, and then it can actually move the data over a different port between client and server. Okay, next, very popular one you're definitely going to be tested on or need to know, and that is HTTP. Okay, so let's talk about this. What port number is HTTP? Okay, good job. Hopefully that's one that you got, port 80. Let's go ahead and peek at what we have in the PCAP. So we're just going to do TCP this time, flipping back to TCP for a little bit. TCP port equals 80. And here we got some HTTP stuff. Now this is a fun protocol to take a look on the wire because HTTP is still going to be clear text. We can still read what's actually happening. We can see the gets, we can see the responses. And what I'd like you to do is come down here. If you take a look at the get that you see, let's go ahead and jump over that scan traffic up there. We're going to take a look at that first get. Hopefully you see it within a few packets. You're going to right click it. You're going to go to conversation filter, TCP. Okay, so here we can see we have SYN-SYN-ACK, and then we can see a retransmission and so on. What I'd like you to do, instead of worrying about too much about that TCP setup, what we're going to do is come down here just to get, and we can see that we're just asking a question of that server. Hey, get HTTP 1.0, get / give me your root page. All right, and we can see that in clear text down below. Now the server acknowledges, and then right away it comes back with OK. So this is where we can see some more clear text stuff. So this is telling us the type of server that's running. Ooh, and we have one of those interesting pictures that we can see on the command line. Let's go ahead and investigate this and see what kind of server it was. If we right click and go to follow TCP stream, what we're going to see here is, again, that Metasploitable 2. So what type of server is it running? Here we can see that it's running Apache 2.2.8 and powered by PHP and so on. Now that banner that we just grabbed, and we can see that clear text from the wire itself. So HTTP, Hypertext Transfer Protocol, that's used for moving that web data, for getting web pages, and even for sending and receiving files. But anymore, you're not going to see as much port 80, especially going out to the web, because it's not secure. We can see the data right there on the wire. All right, our next protocol. Now let's shift this up a bit. I'm going to give you a port number and you tell me the protocol itself. So here's the port number, 110. What do we got? POP, Post Office Protocol. Now POP has gone through a lot of versions and iteration. Now back in the 1980s is when the RFCs came out for the Post Office Protocol. And it started with POP 1, POP 2, and now really if we see it anymore, it's going to be POP 3. So POP 3 is over port 110. But let's go ahead and check it out on the wire. Okay, so I'm going to come in here. Now, POP3 is going to be moving important data around, right? It's an email-based protocol, post office protocol. So let's go ahead and take a look at TCP. We're going to do port, and let's check out port 110. So here I can see POP3. The client is going out and establishing a connection, and we can see the response come back from that server. We can see dovecot ready and so on. There's several things that we can see here in clear text. That's interesting to note. Let's go ahead and take a closer look. Let's right click. We're going to go to follow TCP stream. And here is where we can see some of the login and authentication information. If we come down here, we can actually see some of the message information. And this is actually an email that we can see here in clear text. Right? So we can see that POP3 over port 110 is not going to be secure. We can see it in clear text. So what has the industry done about this? Well, remember this one as well. When you think POP3, also remember port 995. Now 995 is going to use, like we can see here at the bottom of our screen here, we can actually see it just spelled out for us. POP3 over port 995 is actually going to use TLS, transport layer security. So that's going to be encrypted. So POP3 unencrypted, port 110. POP3 encrypted is going to be 995. Now, while we're here, let's go ahead and talk about another email protocol, IMAP. All right. And you can see it here in our follow TCP stream. What are the port numbers for IMAP? Well, if we're not going to be using it securely, then that's going to be port 143. However, anymore, if we do see it, it's going to be over port 993. That's going to be the secure TLS version of IMAP. Okay, so one other protocol that might show up on your test, and that is, what is this? Network Time Protocol, NTP. Now the port number, easy as counting to 1, 2, 3, port 123. Let's see it in action. Now Wireshark can recognize NTP as an application, so let's go ahead and pop that in. NTP. If we come down here, we can see this is over UDP, and in both directions we have port 123. Now what's the point of NTP? Well, it's a mechanism for devices to be able to check in with an authority to be able to accurately set their time. And that's for synchronization. We want to make sure that everybody is on the same page when it comes to timing. And that's what NTP is used for. So remember that, UDP port 123. All right, keeping with UDP, let's go ahead and take a look at one more. This time I'm going to show you the port number, okay? UDP 161. What's the application or what's the protocol that uses it? SNMP. So especially in the networking world, we want to make sure that we understand this one. So let's take a look at it. Now I just said that's UDP based. So let's go ahead and let's just do it from a port perspective. UDP port equals 161. All right. Okay, SNMP, Simple Network Management Protocol. All right, this is a get response type protocol. But what does it do? Well, just like the name implies, it allows us to simply get management information off of our network or infrastructure. So instead of logging into a switch and saying, hey, how many errors are on port 2? That's something that an SNMP tool can do. It can query the network and ask SNMP questions and get responses back so we can have all of that in a central location. Really, it just allows us to monitor the network from a central point. Now, there's other ways that we can use SNMP, but that's the big one. Okay, let's go to the next protocol. How about this one? LDAP, Lightweight Directory Access Protocol. What's the port number? Good job, 389. That's what we're going to use. So let's go ahead and take a look at it in Wireshark. Okay, simply, what does LDAP do? It's authentication and directory services. It's a way of accessing information and authenticating to the system. Now, it's open, it's vendor neutral. It can be used in a lot of different environments. But let's go ahead and take a look at it on that port 389. All right, I went ahead and set the filter for LDAP or for port TCP port 389, and we can see that it's TCP based. So just to keep this at a high level with LDAP, we're just doing our bind request. Here's just a simple login. Great, success, wonderful, come on in. Go ahead and lurk around, see what you want to get. And here we're taking a look at the whole subtree, and then we go ahead and shut down our connection. So a simple LDAP check-in, and that's what we're doing here in this PCAP. So really, we're just knocking on the door here. We're not doing a whole lot with LDAP. There's a whole lot that we could say about it, but just remember that lightweight directory access protocol. Okay, another protocol you're absolutely going to be tested on, and that is HTTPS. What's the port number? TCP 443. All right, good. Now, just so you remember as well, it's also possible that we could have UDP 443. Now that's going to be HTTP 3 over quick. Now, if you're watching this on a Chrome browser or even Firefox and your network is allowing it, the firewalls are allowing it through, it's possible you're even watching this video over UDP 443. Okay, so what's it look like on the wire? Let's take a look. Let's go ahead and go into our display filter. This time we're going to type in TCP.port == 443. Okay, so we can see here that we have SYN/SYN/ACK and so on. So let's come down here to this conversation. I want to just come down to the client hello. And notice here, if you take a look at that client hello down here, I'm just going to right click and I'm going to say conversation filter TCP just to focus in on that one conversation. Right away, the nice thing, at least at this point in time, if I go to the client hello in TLS, I can come down and I can see clear text Wireshark. That's about the only clear text stuff that you're going to get though. Just at the very beginning, what the client is just saying to the server, hey, I want to talk to the Wireshark server on you. That way a server can host multiple different sites. I want to talk to the Wireshark one, and then that server can come back with a server hello. Now everything after this is going to be encrypted, especially if we're using TLS 1.2 or 1.3, and of course quick, which is over UDP. Now more information about how those protocols work on other videos, but our point here, HTTP secure web is going to be over TCP 443, or when it's using quick, it's going to be UDP 443. All right, one last protocol we're going to talk about, SMB. What's the port number? 445. Okay, nice job. Now, what does SMB do? Server message block. It's basically moving files, okay, especially in a Windows environment. If we're connecting to a shared drive on a network and we're uploading and downloading files, a lot of times that's going to be over port 445 SMB. So let's see how it looks. If we come in here, I'm just going to remove this filter, just going to do TCP.port == 445. All right, so we have some SMB stuff. Let's go ahead and take a look at this first conversation. Let's right click. Just going to go to conversation filter, TCP. Just take a look at this very first one. Now SMB has a lot of versions. Okay, so here we're just tinkering around with SMB version 2. What version are you running on your network? All right, so really we log into a system, we manipulate files, and then we're able to download or upload files to another system on our network. That's the point of SMB. So if you're going into network engineering or you're studying for a cybersecurity certification or any network certification for that matter, these are the common protocols that you're gonna have to remember. Hopefully you found this more useful than just going through a bunch of flashcards. You can go ahead and take this video, watch it through a few times, and hopefully it helps you to remember those common protocols and port numbers that you're gonna need to know. Thanks for sticking around with me, and I'll see you on another video.